So it turns out we're not quite done with hypothesis testing, although I promise you this will be relatively painless. Um, the idea here is that when we actually pull a sample data to look at a relationship between two variables, we're not looking at an entire population. We're looking at a small selection of subjects that we decided to test from that population. So in fact, this Pearson correlation coefficient that we've been computing is a statistic, not a parameter. But we can think about there being a population level version of this, and our notation for this is the Greek symbol rho. It looks like a P, but technically this is an R. It's the Greek symbol rho, and we think of it as like the true or the population level correlation coefficient. And so we can ask, based on the data, based on the small sample that we're taking a look at, and based on the Pearson correlation coefficient that we computed from our sample data, does that give us enough evidence to conclude whether or not at the population level the correlation is different from zero? So we have this null hypothesis that we're going to want to test, right? If there's no relationship, we would have a correlation coefficient at the population level equal to zero. So that's going to be our null hypothesis. Our alternative is that we actually do have a significant linear relationship. In other words, the population level correlation coefficient is not zero, is not equal to zero. Okay, so this is the hypothesis test we're running. Here's why we need it. Here, for example, let's suppose we had two variables, and this was all the blue dots is the collection of all the people in the entire population. We have a population level correlation of 0.075. But the idea is when we as researchers go out and collect some data, we only look at a random sample from the population, right? So we can't actually see the blue, we see the red, and we get sample correlations that are estimates of that population level correlation, right? So this is our Pearson correlation coefficient, which is estimating the population level correlation. And you can see that depending on the sample, we can get a wide range of different types of correlations. All right, so it's possible to have a Pearson correlation coefficient that's not zero, even though at the population level it is. So we need a hypothesis test to really test whether the information that we're gleaning from our random sample actually extends to a population level conclusion. So we're going to do this hypothesis test. The null hypothesis is always going to be that the population level correlation coefficient is zero. And our alternative hypothesis, which is what we're trying to side with, is to use a sample data Pearson correlation coefficient computed to show that we have enough evidence to imply that our population level correlation coefficient is not zero. And we call these things significant correlations because it means that there's a significant relationship between the two variables we're looking at. All right. Now, I've done most of this testing for you in the background. Inside of your Week 12 materials, you'll find an Excel workbook called Correlation P-Value. And all we have to do is open this Excel workbook, plug in some of the information we got from our data, and it automatically computes our p-value and tells us how we should conclude our test. So let's open that up, and then let's answer the questions from our other workbook. So here's our correlation p-value Excel workbook. The way that I've sort of set this up, everything that you see that's in kind of a blue, this is something where you're going to put in your information. So if you calculate a specific Pearson correlation coefficient, we're going to put that into this cell. So maybe I got a correlation coefficient of 0.5. Depending on the data you collect, you'll have a specific sample size. Maybe this is 50. And then remember, we as researchers always choose the significance level we want to set for our hypothesis test. So maybe we'd pick like a 0.04. Now what this does is it takes our value for the Pearson correlation coefficient, and it changes it into the appropriate test statistic and uses the appropriate probability distribution, which, by the way, you can tell by clicking into the p-value is a t-distribution. Otherwise, try not to change any of this stuff because it will mess up the way that your workbook functions. So it takes this Pearson correlation coefficient, your sample size, and it sets all this up so that we get a nice p-value coming out of this hypothesis test. So this is where we would compare our p-value against our significance level. Whenever it's under, we reject H0. And remember, our null hypothesis in this case is that there's no correlation at the population level, which means if we're rejecting H0, we actually have what we call a significant correlation. And our interpretation for this is that it's significantly different than 0, indicating we do have a relationship, some sort of association between these two variables. Now let's jump over to our questions over here. We're back in the W12 D2 class Excel workbook. Now in this case, we're asking, for the relationship between x and y, do we have a significant correlation? All right, is this thing significant? Well, we've got a Pearson correlation coefficient of r equaling 0.6, let's call it 622. So if we plug into our correlation p-value, 0.622, we have to update our sample size because we don't necessarily have 50 observations. And remember, when we go to compute our sample size, we want to make sure that we just count out how many rows there are. So we're just going to do count and only apply it to one column to see how many rows there are. And in fact, there's 32. So we're going to jump back over to our correlation p-values sheet and put in a sample size of 32. We can pick our significance level. Let's say that we'll ask if this is significant at our usual standard, which is a 5% significance level. And we can see that our p-value is exceedingly small. It's a 0.0001. So certainly we're below that 5%. And as you can see, this will update to tell us to reject H0, which means our correlation is significantly different than 0. In other words, we call this a significant correlation. So to answer this, we could say something like, yes, our p-value for the hypothesis test for rho equaling 0, or correlation equaling 0, is below our significance level. Hence, we reject the null hypothesis that rho is equal to 0 and conclude that rho is not equal to 0. In other words, there is a significant relationship, and in fact we can replace that with, because we know it's a linear relationship, correlation between x and y. All right, so this is a very long conclusion, and Excel automatically wraps while you're clicked into the cell. So when I hit enter here, it's just going to keep going off further and further to the right. But if you ever double click into that cell, you can kind of read it like a paragraph. All right, so if you want to finish copying this down, feel free to pause the video and write this down. Okay, so what I want you to do next is now take a look at the relationship between x and z. Use your sheet over here, update whatever you need to update, and write out a nice conclusion for whether x and z, the correlation between them is significant. All right, so pause the video and do that. All right, good. So our sample size is the same because if you notice our data here, we have we have the same number of rows for each one of these. So is this relationship significant? We just need to plug in our correlation coefficient here. So this is a negative 0.584-ish, is that right? Yeah, 0.58, I guess if you round up, 0.585. If we keep the same significance level, we leave the same sample size, once again, we have a very, very small p-value, meaning that our correlation is significant. So yes, we conclude there is a significant, and again, what this means is significantly different than 0, which would indicate no correlation at all. All right, so there's a significant, so there's a non-zero correlation between x and z. So this is a much shorter conclusion. We don't mention the p-value, but I did want to go over that discussion as well. Okay. Now, for the purposes of the coming week and over the weekend exercises, I'm going to have you use this correlation p-value to do all of your testing. And you may have to grab the p-value from this particular workbook. Once we start with our linear regression side, we're going to be doing some analysis that's naturally going to test for significant correlations, so we won't need that workbook, the correlation p-value workbook, any longer starting next week. But for this week, this is going to be critical anytime you want to test for whether your population level correlation coefficient is significantly different than 0.